Technology revolutionized the science of wildlife study and conservation. What began with the first radio collars and rudimentary computer programs in the 1960s has evolved to utilize GPS tracking equipment, camera traps, and sophisticated digital models to better understand the home ranges, habitat preferences, and migration patterns of animals. Now we're on the cusp of another leap forward. Hi, everyone. This is Mike Fitz, your resident naturalist with Explore.org, the world's largest live nature cam network. Our webcams provide a portal into nature for anyone with an internet connection. But perhaps there's a way to bridge the gap between wildlife watching through webcams and wildlife science. Through a combination of facial recognition software and camera trap technology, the Bear ID project aims to utilize artificial intelligence to recognize individual brown bears. To learn more about this exciting endeavor, I'm joined by the Bear ID project team. Dr. Melanie Clapham is the director and a conservation scientist for the Bear ID project. Mary Nguyen and Ed Miller are also directors and software developers for the Bear ID project. Mary, Ed, Melanie, thanks so much for joining me today.
Thanks, Mike.
Hi, Mike.
Great to be here.
Thank you for having us.
Good to be here.
I must admit, I'm a big fan of this effort, the Bear ID project, and I think it holds remarkable potential to advance wildlife science and conservation. Before we get into the nuts and bolts of how it works, though, I want to know what inspired this project. Ed, I think you wanted to share maybe a bit of a story about how you conceived this idea.
Yeah, so from our standpoint, Mary and I are both in the high-tech industry in Silicon Valley, and in about 2016 or so, we were getting involved in machine learning and taking some courses on it, and really wanted to do work on a project that could kind of pool our learning together and really help us apply what we were learning about. And around that same time is when we also started watching the Bear Cam on Explore.org. And, was really fascinated by it. We started watching it, and like a lot of people, we couldn't ID any of the bears. We started reading the discussion boards and watching the play-by-plays, and slowly started to be able to tell some of the bears apart. And that was kind of the aha moment. We're like, well, if we can learn to do this, maybe a machine can as well. And so we found our project that we really wanted to work on, and we started developing Bear ID as kind of a fun learning exercise to kind of expand our machine learning capabilities. And one of the big parts for machine learning is the data. And for this, we needed photos of bears where we knew who was who. And so we reached out to, we received some photos from Bear Cam viewers and from Katmai National Park. But we also reached out to a community called Wild Labs, which is a tech for wildlife community trying to bridge those gaps. And that's where we met Melanie, who was coming to a similar point in her search. Melanie, you have some thoughts there?
Yeah. So my kind of journey to the project was a little different. So I'm a conservation biologist. I focus on bear research, and I've been studying bears on the west coast of British Columbia in Canada for just over 10 years now. And most of my research is concentrated on behavioral ecology of bears and trying to understand their social behavior, so how they interact with one another. So I use a combination of direct observations, mainly from boats, but also from viewing platforms like at Brooks, and also camera traps as well. So trying to recognize individual bears over time to study how they come together and how they interact, mainly using scent communication and scent marking onto trees. So obviously over the years, I've spent a lot of time watching bears and trying to recognize between different individuals and understand different individuals and their behaviors and how that changes. And it's so difficult. It's so difficult to recognize between individuals. As you all know, they change a lot within a season and across different years as well. So spent a lot of time studying images and videos, trying to recognize between individuals. And so I kind of started to wonder whether there could be a way to automate this process so that we could study bears a bit more systematically and a bit more objectively, and so that other people that study them throughout the world would be able to recognize between individuals without having to spend kind of 6 months of the year in the field for multiple years. So I joined Wild Labs to see if any research like this was already ongoing. There'd been some research, obviously identifying between individuals for species with kind of distinctive markings, but I wasn't sure if that had been done for species that lack these unique markings yet. So I kind of joined Wild Labs to find out more and to see whether we could maybe use facial recognition for bears. And that's when I met Ed and Mary.
And Mary, can you tell us how this software works? How does this machine learning work to recognize individual bears?
Okay, so basically the flow for a bear ID is that there are 4 parts. In the first part, what it does is that it finds a face, and then within each of the faces, it has the eyes and the nose. And then in the next step, it takes that information and it creates a crop out of it, just basically, just the face. And then in the next step, after that, it generates the face features. So basically, what it thinks are, features specific to a bear. And then the step after that will take those features and then decides of the bears that we know about, which bear does this match the best? And then it says, okay, it's bear, whatever, 480 or something. So the way that we got the program to work is that we use machine learning. And what machine learning is and how it's different is that it's not like traditional programming where you tell it the actual rules of what a bear looks like, what a face looks like, and what could distinguish one bear from another. This machine learning program kind of learns it on its own. So you give it a bunch of information, like a bunch of images, and where the faces are and where the eyes and the nose are, and then it'll find it itself. It learns it through time. So what we had to do is that we would take images that we do have, mark out the faces and the eyes and the nose, and then we feed it to it, like just thousands of images. And then eventually it learns and it creates an algorithm where it's able to come up with, as close to the answer as possible. So basically we do that with each of these programs, and, it managed to do pretty well. And so, yeah, that's how it works.
And speaking of, photographs and teaching, a machine to do this with facial recognition technology that works on people, though the people developing that, they utilized millions of photos of people to develop that technology. So Ed, I'm wondering, how much of a challenge was it to develop bear facial recognition technology with only a few thousand photos to work with?
So on the one hand, the small data sets actually made things a little bit easier. And what I mean by that is, these large data sets take tons of storage, tons of processing power, and it's just very daunting. So, I think the fact that we had a small data set to start with was an advantage in that we thought we could actually achieve something. We could run this on a moderately priced computer that we built and ran at home, which we nicknamed Otis, by the way. So that was the good side of the small data set. But as you said, most of the real machine learning uses these large data sets, or so-called big data. With a smaller data set, it really kind of limits how accurate we can make these algorithms. Humans are really good at generalizing what they learn. For example, a small child can learn about a cat, and then when you take your child to the zoo, it's quite good at pointing to a tiger and saying that's a kitty. But machines can't do that so well. They're very rigid, and you need to give it lots and lots of examples before it learns how to differentiate between things. So one technique we used is to try and make our data set a little bit larger, and use something called data augmentation, where we take the existing images that we have and we modify them a little bit. For example, maybe we can change the colors a little, or add some noise to it, maybe change the lighting on it to imitate different conditions that we might see out in the wild. And that augments the data set a bit. That's pretty good for the face detection type stuff, but you can imagine for Face ID, you can't change a face a lot and still have it be the same bear. So it didn't really help us a lot there. So what we had to do in that case is, because of our smaller data set, is try to focus on the populations that we're working with. So where these large human face recognition applications can recognize new humans that the network has never seen before at a very high accuracy, for us, we really focus on a specific population, like the Brooks Falls bears, or the bears that Melanie studies at the Night Inlet in British Columbia. And we basically have to train our networks on those specific populations. And then as new bears come in, we need to learn and add them to the network. So it's a little more challenging to keep it to fresh and relevant, but yeah, it does a pretty good job at the base.
And a follow-up question to that, Ed, is since bears change in appearance from summer to fall as they gain weight in preparation for winter hibernation, how does the software compensate for that? That's something that, humans don't normally experience. You're not normally going through these tremendous, swings in body size each and every year, but every bear does that.
Yeah, that drastic change in body appearance was definitely one of our stumping points early on. And that's one of the main reasons we decided to focus on faces. The faces seem to be a lot more consistent across the year. There's certainly some fur changes, but the weight gain is not as evident on the face as it is on the rest of the body. But even with that, for the best results, the same bear does change across the season and across the years, and they can be wet, they can be dry, they can be in light, they can be in shade. We need examples of all of these things for each bear to make the algorithm work really well. So kind of like I was saying before, the application doesn't generalize that well. We need to show it examples of just about every kind of condition we want to show it. So the bears that we have more images of, like Otis, where we have hundreds and hundreds of images of Otis, it does quite well. But the bears that are a little less photographed, so maybe a scaredy bear or somebody that's not as photogenically or not as camera friendly as some others, those are a little bit more challenging. So we need to keep building up that data set to compensate.
And Mary, how well does the software work currently?
It actually does pretty well. So the first part, which finds the face, does amazingly well because it's pretty generic, and we have quite a few images for that. So currently it's doing 97.7%, which is really, really high. It occasionally misses faces that are like pretty small. So, if you're taking a picture of a bear from really far away, and then it also detects extraneous faces. Like you'll think that, a bush or some rocks or some water or things might be a face and isn't. But other than that, it does really well. The other part of the program that actually identifies, picks out the features of the faces and tries to ID the bear doesn't do nearly as well because, like Ed was saying, we don't quite have the number of images that are needed to perform a little better. So that part of it does about 84.2%. And actually, if you compare it to some of the other projects that are going on with animals, like identifying animals that are that don't have natural markings, it actually does really well. So there are projects in existence for lemurs, for instance, and that's doing 83%. And then there are golden monkeys, and that's at 78%, and then chimps at 59%. So relative to those projects that are going on right now, ours is doing pretty well. But yeah, more pictures. That's how we get better.
And so we've talked a lot about how the software works. Melanie, though, I'm wondering, what applications does this have for your research or maybe other wildlife research in the future?
Yeah, absolutely. Quite a few, actually. So we've talked a little bit about camera traps, and we're really excited about how we could combine Bear ID with camera trapping, which are kind of two what we would class as non-invasive techniques. So by combining these two techniques together, we could set up camera traps across a landscape and identify individual bears and track their movements over space and over time as well. So we could use Bear ID in combination with other types of technology to help to understand the behavior of bears, the movement patterns of bears, perhaps dispersal of young males when they leave their home range to establish, or their maternal home range, and go and establish their own home range. We could study in a little bit more depth where they go and how they move. So one thing we're interested to see is whether we can gather similar data as to what would be collected by putting GPS collars on bears, but doing it in a more non-invasive way, by identifying and tracking individual bears over landscapes and over time, using Bear ID with camera traps. And if we can use them with camera traps in this way, we can also gather and understand populations, understand the number of bears, how many bears we have in certain areas, the densities of bears, and all this information comes together to inform management of populations and species and conservation action that's required as well. So we're really kind of interested in how it can help to further understand populations and their behaviors, but also things like research like mine in the past, looking at social behavior of bears, understanding life histories of bears, perhaps for individual females, the number of cubs females have in a lifetime, things like that we can study with cameras and Bear ID. And another thing that's quite interesting to us and really important is to speed up the amount of time that is taken. So this automated process of ID hopefully can help us to analyze and process camera trap images and videos a lot quicker. And anybody that's done any kind of wildlife research using camera traps knows how long it can take to go through this kind of data, pull out individuals, identify the age of bears, the sex of different individuals. It takes months. So you've not only, spending months actually collecting the data, but then afterwards doing the processing before you even get to the stage where you're actually doing the data analysis and trying to answer the questions that you set out to. So if we can speed up that processing of data, then we can actually get to the questions quicker. And so we're really excited about the kind of automated aspect of Bear ID and how it can hopefully help us to speed up data processing. And then a last one that's gained quite a lot of interest through our project is how Bear ID could be used for human-wildlife conflicts and coexistence. So to understand conflicts between people and bears a little bit more, how we can recognize individual bears and understand, for example, if we're having problems with a bear in a certain area, is this one individual bear? Is it multiple bears? And obviously that can have a big implication, or that can have a big impact and implications for the type of management that is decided upon for tackling that situation. So we think that it could have definitely positive impacts in terms of wildlife research itself, the data that's collected, the way that the data is processed, but also kind of conservation action as well.
And if we could continue to sort of dream along those lines, Ed, I'm wondering how might this technology be potentially applied to BearCam or other webcams?
So, as I said, we started the Bear ID project running on a local computer. So the first thing we had to do was start to move that into the cloud, which we have started doing through a grant that we received from Microsoft AI for Earth. And so once we have that in the cloud, we could actually take feeds from the BearCam or other cameras like that, other cams like that, and start to process that data in real time on the fly. And so BearCam data can be fed into the Bear ID application, where the Bear ID application can look frame by frame and identify the bears, find them in the photo, could potentially count bears, and ID which bears are which. And this raw data can be very useful for the bear monitoring program, for other kind of research purposes, somewhat like what you've done with the Are You There, Brown Bear application that you have running with the Explore cams today. For bear cam viewers, then we could take that data and start creating, maybe in the basic version, could just display a still image that updates from time to time and shows the location of which bears are where. But we could take that a little bit further and do a fully annotated video stream. And there's a example of that we've done through Bear ID with a video clip from Otis, being Otis, sitting in the office and doing some fishing. And I think this is a clip that a few people have seen before, and we'll post a link to that as well. Of course, in that video, I actually show when the Bear ID is getting the ID correct or not. But in a live feed, of course, we don't know which bear is there. That's why what we're trying to determine. So this is an opportunity to perhaps leverage the Bear Cam community. Perhaps we could have something where the Bear Cam community can vote on which bears are which, and we can use some sort of collaborative effort to verify Bear ID and check how well it's doing. And when it's getting it wrong, we can use that to create new training data and improve the process. And that same data can be used to feed into the applications we use for research as well, and grow that whole process and make it better. And one day I hope to be able to receive a notification that lets me know when Otis is on camera, so I don't miss any moments that the big guy's out there fishing. So there's lots of great things we could do together.
And I just have one final question for the three of you. I'm going to throw this one to Melanie first, and Mary or Ed, if you want to chime in, you're welcome to. But I'm curious to know, yeah, Ed, you touched on it, but yeah, what's the future hold for Bear ID? What are your next steps?
Yeah, so we're at the moment we're in the process of further developing Bear ID to work for camera traps. So doing some retraining and testing using camera trap footage that we've collected at the field site where I work over the past couple of years. So that's kind of what we're doing in the immediate future. But yeah, so further training and testing and understanding how the system works and trying to kind of perfect it as much as possible. And then we're also interested to further develop this and see if we can develop this for other bear species too. So looking at how this could be used for species in other areas and more threatened species as well. So that's something that we're really kind of interested in, how this can be applied. I mentioned before about, the fact that bears don't have distinguishing markings. So there's already been some research done by other researchers on primates, and now we're starting to see with our group and a couple of other groups looking beyond primates at kind of other large carnivores that don't have distinguishing markings, and whether we can use facial recognition technology to help us study those. So bears are a really obvious group for that, because most of them don't have distinguishing markings that can be used for ID. So that's kind of one of our main focuses going forward.
Yeah, I think Melanie touched on most of the points for us as well. We started this application as an open source project, so it's freely available for people to use. And so with Melanie, we're focusing on getting the bear species as well represented as we can, but we'd love to see this be picked up by other researchers in other fields and other applications, and make use of these technologies in a lot of different conservation applications.
I look forward to that day as well. Been a great conversation. I learned a ton, and I'm certainly looking forward to the future of this technology and wildlife study. Ed, Mary, Melanie, thanks so much for joining me today.
Thanks, Mike. It was great to be here.
It's been fun.
That was Dr. Melanie Clapham, Mary Nguyen, and Ed Miller They're the team that are developing the Bear ID project technology. If you want to learn more about their work, please visit their website. You can find it at bearresearch.org. My name is Mike Fitz. Thanks for watching. And as we like to say at explore.org, never stop learning.